Okay, here we go with our next little bit of class code. We're going to make a class called dog, which is used to make dog objects. And we should actually get to a point where we're making those objects today. As always, I kind of invite you to code along with me, right? Actually type things out. If you just watch the video or you just copy and paste source code, you're not going to learn it anywhere near as well. Pause the video in certain parts if you need to. Type out what you see on the screen, unpause, and keep watching. Without any further delay, let's hop into this. I'm in IntelliJ. I'm going to make a new project by going to File, New Project. Our JDK is already selected, so we're going to go Next, Next. And I'm not quite in the right folder, so I'm going to switch folders. You may already be where you want to be. I'm going to switch to my AP Computer Science A folder. In this project, we're calling Dog, D-O-G. I'm going to ensure there is a subfolder. It's possible that if you did not change your project location, that IntelliJ auto-created this for you or typed it out for you. But subfolders are going to be nice. We're getting to a point where we're going to have multiple Java files associated with the same program. So this subfolder is going to help us keep those projects organized. I'm going to finish. It's going to tell me that dog does not exist, this subfolder I'm trying to create. So let's create it in this window. I'm going to expand my project folder. I'm going to right-click on the SRC, make a new Java class. This one we're calling dog. IntelliJ already created my class header for me. That's one of the 4 pieces, right? That's one of our 4 things that the class is responsible for kind of defining, or one of the 4 pieces of anatomy. I'm going to go ahead and comment this because I want you to think for a moment, what is the purpose of a class header? What does that do? Right? This names the class and defines the access level. In this case, it's public. All of the classes we make are still going to be public, but I'd like you to recognize that there are more options out there, right? Such as private. Okay, that's one of our pieces. It's the easiest piece. Inside the class, this is super important. Notice where I am declaring these variables. They're special. They're not the normal local variables that we've been working with. These are called instance variables. Okay? Instance variables, they correspond with attributes or properties about your object. Right? In the case of a dog, we're asking what type of properties do dogs have? Something like weight, breed, fur color are all super important, but also maybe some indicators about what is the current state of the dog. Right? Is it sitting? Is it standing? Those are the type of things that we're going to add on here. Okay, so I'm going to declare our very first instance variable, private string breed. Order on these instance variables, it doesn't matter, right? The order that we declare these things in is not super important. I tend to try to identify what instance variable I think is most important, and it is kind of like towards the top. In this case, I think breed. I think breed is like one of the most important things about a dog. So it's going to show up first here. Notice that this looks just like a variable, a local variable, and that we have a data type and a variable name. What's different here is that we have an access modifier. In this case, private. All of the instance variables that we do in this course are going to be private. I'll explain in a later date why you don't want to really do public instance variables. But what you really need to know right now is they need to be private, and that's what we're going to be working with for the most part. So when you're creating these objects or these classes that are used to define objects, you want to think, what types of properties do they have, right? And then you also want to think, what type of actions can they perform? Our instance variables represent those properties, right? This is an individual property, right? Breed is important. Weight is important. These represent one property each. Collectively, these 2 things make up the state of the object. That's one of the things a class is responsible for kind of outlining or defining. Something like weight, I would probably include a comment here. Something along the lines of like, what unit is this in? You know, maybe we're measuring our dog's weight in pounds. And I've chosen the double data type because we can have like a fractional weight, like, you know, 17.5 pounds, for instance. Okay, so we got 2 instance variables here. Maybe another good comment is, what is the purpose of our instance variables while we're learning that, right? These are instance variables. Another synonym word, an interchangeable word for instance, is object. So these are object variables, or variables that belong to the object. So I would maybe say instance variables represent the object's state collectively, right? An individual one is a single property or attribute, but collectively they represent the state. So other instance variables we may have is maybe a string that represents the dog's fur color. Maybe we have a string position that tells us what the dog's current position is. Now, in the future, the super advanced computer science stuff, we get into something called enums, where these things are set. In the case here, I'm using a string, and so maybe a good comment would be, what positions are going to be valid within my program? What am I saying? Maybe this string, while it could be any bit of characters, right? Any combination of characters and numbers, I'm going to only limit it to things like sitting or standing. Running may be a possibility. See what I mean? Fur color, maybe it's a similar thing, all right? Maybe we only are going to ever allow like brown and black and white, whatever fur colors you want, but I think you get the idea. All right, these are pretty good comments, kind of outlining what these variables can be. The last one I'm going to throw in here is a Boolean to indicate if we are barking or not, just to give us some variety. Maybe barking is ultimately a position in our program. I don't know, little nuances like this are why programmers are going to get paid big bucks. But as always, this Boolean, there's only two states. Either the dog is barking or it isn't. So those are our instance variables, and I'm going to stop there. You may think of more that you would want to include, but I'm just going to proceed with these 5 instance variables. Purpose of our instance variables is to represent the object state. These things, they're variables. They can change over time, and so that's simulating changes with our dog object. The next thing I'm going to include here is a third piece, right? It's the constructor. What's the purpose of the constructor? The purpose of the constructor is to set the initial state of the object by initializing the instance variables. Initializing. You got a suggestion for me? Initializing. It's Google or IntelliJ is supposed to have spell check. Google's better at it. Thank you. Okay, so here I declared instance variables. Declared, that's it. We've created the variables. They're going to exist whenever we create an object. In fact, every time we make a dog, each dog is going to have a breed, a weight, a fur color, position, a barking. Okay, they're going to get their own set. Recall that when we were talking about objects, that's really all it is. We have these 5 variables, and we want to group them together and keep them together. That's all an object really is a collection of data, but we get to kind of define what that is. Here, the constructor is going to set the initial state. It's going to assign values to these things. And in my case, I'm going to create a constructor, public dog. This is the header of my constructor. And if you kind of notice, it looks an awful lot like a method header, right? We got like a name and we got some parentheses that kind of indicates that it takes a parameter or it could take parameters. But what's missing here is a return type, right? That is the biggest difference between a constructor and a method. We'll plug in some methods here in a little bit. Another key distinction is that the name of the constructor must match the name of the class header. Capitalization matters, right? Here we see dog, name of my constructor, dog, name of my class. So here we have a constructor. The purpose of that is to set the initial state of the object by initializing the instance variables. I'm going to give this constructor a body. And then here, we're going to kind of throw in some default, I guess is a good term for this. We're going to give these things some values, right? I'm going to take my breed instance variable and give it a value, right? I don't know. How about a husky? Right? Breed is a string. So I'm giving it a string value here. One thing I want you to notice is that our instance variables are declared in the body of the class. That means that their scope is going to overlap into this constructor body, right? These instance variables, they don't stop existing until the class stops, or the object stops existing, right? The end of the class is where they no longer exist. If I tried to access breed out here, IntelliJ is going to get mad at me. Okay. Let's finish initializing these things. All right, I've got breed. How about our weights? Right? We're going to take a weight, and I'm just plugging in like default values. Right? We're just playing with it, really. Let's say that our husky weighs in pounds, I don't know, 60. Right? It is a double, so it could be something like 60.3, just as an example. For our color, how about black and white? Position. Initially, our position for our husky is running. Don't know. Depends on the context of your program. And barking, let's go with false. Okay. This is going to maybe make a little bit more sense when we actually create our very first object. But I'm just plugging in default values. We're giving some values to these instance variables, but not until we actually create a dog. More on that later. The fourth and final piece of my class are methods. And the purpose of methods are going to basically, they represent our object's behaviors, right? Represent the object's behaviors. The main way that we kind of accomplish that, right, because we're trying to simulate things that happen in the real world, but we're doing it in code, the main way we accomplish this is by modifying the instance variables. We show a change in state by modifying the state. That is, these instance variables. For instance, right, I got this barking instance variable. Initially, when I create my dog, it's not going to be barking, but maybe it starts barking. I would have some type of method for this. Public void. How about bark? Maybe, since this is a Boolean, this bark method just works as almost like a toggle, right? If we are currently barking, we stop. If we aren't barking, we start, right? So if we are currently barking, we set barking to false. Otherwise, barking becomes true. And I'm going to show you a clever way to kind of rewrite this, but this is what I mean. We're going to represent a behavior, in this case, barking. And the way we actually achieve that representation, that simulation, is by causing a change in the state of the object. If the dog is currently barking, I'm going to toggle it, right? We're going to say that it stops. Otherwise, we're going to start barking. Okay, this is a behavior. Let's take a look at the header here. Right, we see our access level, public. Void, we're not returning anything here. We're just modifying the state. And then the name of the method, and in this case, I'm not taking in any parameters. You'll notice that the reserved word static is missing, right? And if I do that, IntelliJ doesn't like that. Static is kind of complicated, but just think of static as the opposite of object orientation. We're working with objects. All of these methods that we're going to be writing, for the most part, are going to be object methods. They're called instance methods. Keep in mind that word instance is synonymous with object methods. Static is the opposite of that. Static is when you don't need objects at all. But because we're working with objects, we're going to leave off the word static. So here is a behavior. Let's maybe look at a couple of more behaviors that we can maybe want. Sorry, I want to add it to, let's add it here. Maybe we got public void run. Okay. Think about this. This is a behavior, right? Dogs can run. I want to simulate this behavior, and I can do so by causing a change to the state of my object. These instance variables collectively make up the state. And while I'm only going to change one attribute, you could change more, right? We could modify the state by changing multiple instance variables. But in this case, in order to say that my dog is running, I'm just going to take my position, one of those attributes, and I'm going to say, oh, now we're running. That's it, right? This is a behavior. Run is a behavior. The way that we simulate behaviors is by causing a change in the state of our object. In this case, I'm taking position, which is one instance variable, one of the things that make up the state of the object, and I'm changing it. I say I'm changing it, right? The default was running, and now I'm saying, okay, what about something else, like sit, public void sit. I'm going to plug in a body here, and so maybe that edits the position by saying, hey, we're sitting now. Okay. Let's try these out. To do that, we need to make an object. And in our last video, we talked about how I don't want to plug in a main method in my dog class. One of the major benefits, one advantage of object-oriented programming is that we can kind of create a class that is designed as the blueprint or template from which objects are created and reuse it in other things. If I plug a main method into this program, that's it. It's got a main method in it. The only way that I can edit out that main method, the only way I can open up my options is to go into the literal source code and edit the main method. I don't want to do that. I want to be able to take dog and plug and play it in other programs. So I'm not going to plug a main method in here. Instead, I'm going to right click on the SRC and do a new Java class, in this case called driver. I'm going to plug in a main method with PSVM. And we're getting ready to create our very first dog. Let's see how we can do that. So an object can be constructed or instantiated. Big word, but the root of it here is instance. Okay, instance is synonymous with object. An object can be constructed or instantiated using the new operator. We've seen the new operator before. The above code segment will construct an instance of dog. We're going to say new dog. You've seen the new operator before. We've actually made objects before, technically. And here you see dog. That should also look a little bit familiar to you. We'll come back to that. You will likely want to store the object in a variable. Interesting. Here I actually have variable declaration. We have dog, a data type. We have Scruffy, a variable name. So, usually an object is constructed and saved into a variable using one single construction statement. So we're about to create our very first dog. We're going to create a new dog, and this will actually create our object, and we're going to end up saving it into a variable. That variable being Scruffy, and the data type of it being dog. So this is our syntax. In order to basically do all this, keep in mind there's actually two things happening. There's object creation and there's variable declaration, and then I assign it, right? I'm storing that object in that variable. This is our syntax. We're going to have a data type, a variable name on the left-hand side, and on the right-hand side we're actually doing the object construction. Let's look at some examples. Right, we're going to make a dog here in just a moment, but we've actually made some objects before. We've made random objects before. We've made scanner objects before, right? Left-hand side is variable declaration. This is a random variable called Randy. And it is actually storing a new random object. This is a scanner variable called input, and it is actually storing a new scanner object. This particular scanner reading from system.in. So we've actually done this before, and we're about to do a little bit of this. So the right-hand side is where we actually make the new object. This can actually exist in isolation. Again, there are two major ideas happening here, and even though we're going to combine them quite frequently, I would like you to keep that in the back of your mind. That is two different things. Object construction, right? We're calling the dog constructor here, right? I told you this looked familiar. Where have we seen this before? Right here. This is similar to a method call, right? A constructor is similar to a method. But in this case, I'm not calling a method. I'm actually calling the dog constructor. Right? So we're saying, let's make a new dog. That's one idea, creating the actual object. The other is variable declaration. The left-hand side of this construction statement is declaring a dog variable. The assignment operator is ultimately telling that variable to store or reference the new dog object that we just created. And from that point on, if I want to refer to this dog object, I'm actually going to refer to it through the variable, through Scruffy. Let's do this. I'm in my driver. I'm going to create our very first dog. We're going to give it a variable name. Give me a dog name.
Fluffy.
We have a dog, Fluffy, and it is a new dog. Right? TailJ's not mad at me. This is good syntax. We're creating a dog variable, Fluffy. It is referencing this new dog. And then right here, we're calling the constructor. Okay. Whoa. All right. There's a lot of stuff that happens here. For one thing, this is going to make a new dog. That dog is going to have 5 variables wrapped up inside of it. Okay? And as I told you, this is actually going to call the constructor. Not only is that dog getting created, it's got those 5 variables. These values are then being saved into those variables. How do I know that? Let's take a look at the flow of this program, right? When I say new dog, this gets executed. It's going to go into the dog class. It's going to see this constructor, and then line by line, it's going to start executing these things. In this case, I'm saving in values to these instance variables, right? So that will create that dog. It'll assign those values, and then that dog object gets saved into this variable, and it's there. I've created a dog, right? From that point on, I can then tell my dog to do things, right? We got our dog Fluffy, and I want Fluffy to sit, maybe. What does that do? Right, here's our object, and I'm telling it to perform an action. In this case, a method. The flow of this would be, let's take this dog, let's tell it to sit. Well, we're going to execute the sit method. What does sit do? It changes the position to sitting. Maybe I want Fluffy to run. I'll take Fluffy, and I'll tell it to run. When we execute this, it's going to take Fluffy and change its position to running. And you may be sitting there thinking, okay, is that actually happening? Well, in order to see those changes, we need to actually access the variables, and those are private. We're going to pick up in the next video with showing you how to access those variables, how we can see that these changes are being made to the state of our object.